Welcome. This is a presentation on Juice for All, company's website by Burgerlicious Corp. The team conducting the evaluation and presentations are David Coenen, Christopher Dalisay, and yours truly, Mike Lee. Burgerlicious Corp was approached by the customer Juice for All to evaluate their online website. The website has multiple features, such as a product store, account information, and ability to process credit card information. As a company lives, eats, and breathes Burp Suite, which lends itself to our company name Burgerlicious, we utilize this tool to examine the customer's website for vulnerabilities and weaknesses that may arise. An evaluation is being conducted on what data is exposed and customer information that may be leaked. Are there exposures to the system itself that allows attackers to access unauthorized spaces? We're here to find out. As we find these vulnerabilities, we will suggest mitigations per finding.
So the Burp Suite tool, at a high level, is an integrated platform and graphical tool for performing security testing of web applications. It supports the entire testing process, from initial mapping and analysis of the application's attack surface, so viewing the vulnerabilities, to actually finding and exploiting security vulnerabilities, so the actual penetration testing portion. It's a tool developed by Portswigger, and there's two versions. The one we'll be demonstrating today is the Community Edition, but there's also a Professional Edition if the client so chooses to purchase it. Burp Suite is a proxy-based tool that allows the penetration tester, in this case our team, to watch messages go between a client browser and a web application, in this case our client's web app. This tool allows capturing of a few things, some of which are bulleted here on this slide, including interception, which we utilize the proxy tool for, intercepting the actual calls in between. Replication, which we utilize the repeater tool for within Burp Suite, that allows for repeating calls that we've captured. Modification, which we utilize the repeater and intruder tools for to modify the calls that we've captured. And also the mapping of the site that we leverage the sitemap tool for, which allows us to have a consolidated place where we can see all the information gathered so far from Burp Suite. The first way we'll showcase Burp Suite is through a found login vulnerability within the login module of our client's web app. So on the screen is the login module with a test email and password, and the UI is indicating invalid email or password. So let's go ahead and take a closer look with Burp Suite. Utilizing Burp Suite's proxy tool, we can go ahead and intercept the communications between the browser and the web app. And you can see on this particular call, there's a post call to the web server, along with the payload of email and password. Now, if we go ahead and save that to the repeater tool, we can go ahead and make these calls as often as needed. In this case, we're making the same exact call, and the response is a 401 with the invalid email or password. Now, if we go ahead and tweak this call with a common SQL injection technique by adding a single quote in the email parameter, we can see that the response instead is 500, and the error returned not only tells us that it's a SQLite backend, but also gives us the complete SQL for how it's validating the user. With the knowledge of the query itself, we can go ahead and put an or true in the statement to always make the select statement return true, close it off with a couple of dashes to comment out the rest of the query, and we can see that the response back is a 200, and we are authenticated as the admin. Seeing the success in Burp Suite is one thing. We want to take that and go ahead and try it on the web app UI. We're putting in the exact parameter that we put in for the email in Burp Suite, and then our negligible password. And we can see that we've logged in successfully as the admin. A few of our suggested mitigations for this vulnerability include basic client-side and server-side validation on the value being passed. The value that was passed should have never been considered an email. Unexpected errors returned from the server level should have never surfaced to the client side. For instance, the 500 that was returned with information about SQLite and the query itself should not have made it to the client. Utilizing prepared statements with parameterized queries alongside utilizing stored procedures help as defenses within the code for any potential SQL injection attacks. And additional SQL injection mitigations can be found on this OWASP link.
Here we demonstrate the brute force password attack on an administrator account. First things first, let's find an administrator email for the login page. Looking around the website, we can see that the administrator used the account to place a review for everyone to see. We'll take note of this email address later. Next, we head over to the login page and we type in test for the email address and test for the password, and we click login. Heading back over to Burp Suite, we're able to see the post request proxy from the website. At this point, we can see the test email and password fields that we entered previously. Now we can right-click on the post request and send this to the intruder tool inside Burp Suite. Inside the intruder tool, we can see the post requests, but we need to clear the payload marker from the original request, so we hit the clear button. This will allow us to send repeating requests to the website when brute forcing the password. Now we can replace the email account with the administrator email we found earlier and add the payload markers to the password field by clicking Add up top. And these are the markers that would tell Burp Suite where the payloads will be placing the attempted passwords in the post requests. We can now move over to the Payloads tab and load in the rainbow table file we will be utilizing to brute force the password on an administrator account. As you can see here, the rainbow table is loaded, and we can now start the attack by clicking Start Attack. The attack has concluded, and we're given a 200 status and the password returned. And you can see here it's admin123. From here, we can use the admin123 password with the administrator account we found earlier at the login page and log in as administrator. Mitigation suggestions include utilizing a complex password policy, one that includes special character requirements, a mixture of numerical and alphabetical characters, and no dictionary words. A suggestion of configuring a minimum length password policy, limited number of retries, a CAPTCHA implementation to verify human interaction, tokens for administrator, and two-factor authentication should help fortify the customer's website against brute force password attacks.
Next, we're going to show that our client has broken access control on their website. This exploitation allows us to view other users' shopping carts. You can see that currently we have Burp Suite open, Intercept is on, and we have a fake user account that has some items in their shopping cart. As we forward packets through, we see that there's a GET request asking for basket 6. If we take this and send it to Repeater, and then modify the basket ID, and go ahead and forward that request on, we actually end up in another shopping cart than the one we originally had. As you can see here, orange juice, egg fruit juice, which is not currently in our shopping cart. So if we go back to the original cart and resend the intercept till we get to the basket request and then modify it and continue forwarding these packets on, we're actually able to drop into another user's shopping cart, and from here we can go ahead and modify and change things as we see fit. So this is an insecure direct object reference, or an IDOR. It's due to access control not being properly implemented on the web server, and references to data objects are very predictable, meaning, as you can see, we were able to change from basket 1, basket 2, or basket 6, and we can go ahead and execute the forwarding of packets to pull up data that we're not supposed to access. To mitigate this, we need to avoid direct object references, so we need to use random hashes or strings rather than something that's very predictable like shopping cart 1 or cart 2 or basket 1. And we also need to implement detailed access controls. That way we can verify that the user actually has permission to access those specific objects. Another exploit we are able to find on our client's website is the ability to forge feedback as a different user. As you can see, our intercept is on. We've captured the incoming post packet, and we are logged in as a different user. This shows we are user 21 currently. Taking this and forwarding it to Repeater, we can go ahead and modify our user ID and resend the packet. From here you can see that we are successfully able to send it and upload that feedback as user 2. Going back to our original intercept and trying to send the packet as user 2, we're able to see that we are actually able to upload our feedback as a different user. Once we're able to enter the admin console, you can see from here that it actually uploaded as user 2. This is another example of indirect object reference. Once again, access control is not properly implemented. references to data objects are also very predictable, meaning that you can see users are sequentially numbered. We need to mitigate this, we need to avoid direct object references using a random hash, meaning that the user accounts need to be randomized. They can't be predictable. Also, we need to implement detailed access controls. So we need to verify that the user who's actually uploading that is user 2, not user 21 posing as user 2. So to demonstrate some of the vulnerabilities on our client's website, I'm going to show how we can do a forged feedback, how to access the administrator account, and then get to the administration page to show that we forged that feedback. Currently, I'm logged in as user123 at 123.com. Go to customer feedback, turn our intercept on, and our comment. We're going to go ahead and test the forged feedback. Go ahead and adjust our rating to 2. And then go ahead and enter in the answer to the CAPTCHA code. Our intercept is currently on. Go ahead and submit. Continue to forward through until we see our user ID, CAPTCHA ID, CAPTCHA, the test, and our comments, and our current rating. So we'll go ahead and modify this to user 2. We want to remove who the actual author is. And we'll go ahead and change the rating to 0. We're going to go ahead and continue and let the packets continue through. And you can see it says, thank you for your feedback. So we are actually able to send feedback as a different user. Now we're going to go ahead and log out and go ahead and test if we can actually log in as an administrator. So we're just going to do a random pool of username and password, or email and password. We're going to turn our intercept on, try to log in. And we can see here, email, password. We're going to go ahead and send this to the repeater. And using this, we want to see what happens. We send it through, and we get a 401 unauthorized. Let's try to change it to something we know could potentially allow us to access through SQL. We'll go ahead and resend that. And we see we have a 500 internal server error and that we have a SQLite error. It's an unrecognized token. So with that, we can try our SQL injection. Send this. We see that 200 OK. So we are able to bypass the login. Go back to the proxy, and we'll go ahead and change this to what we just used. And we will continue with the intercept. And we're able to actually access the admin account this way. So now we're going to go ahead and head to the administration page to see if our feedback worked also. So yes, you can see the registered users. And as we come down, we can see that yes, the forged feedback worked as customer 2. When we click on it, we see that it's user 2 that sent this in. And to correlate, user 2 is jim@juiceshop.op. So the administrator, when they come in, will see that Jim sent this in, not us from our account.
Thank you for joining us for this demonstration and assessment of Juice for All company's website. This allowed us to show you some useful ways to utilize the toolset in Burp Suite to intercept, replicate, and modify packets that are being proxied from our website. Demonstrating vulnerabilities with an account issue, password cracking, personal account intrusion, and an attack that can affect an entire company's business. All findings were given to the customer, along with suggested mitigations that would help remediate the issues found. Hope you found this presentation useful, as Burp Suite is one of our favorite tools to use around the office, and it was our pleasure to share it with you.